In this question, for the given circuit, we are going to find the Thevenin's equivalent resistance between P and Q terminals. The Thevenin's resistance between P and Q terminals we are going to calculate. That is RTH is how much? General procedure for calculation of Thevenin's resistance is across any two terminals, that is at terminals of interest where you want to calculate the Thevenin's resistance, you must apply a test voltage source, and because of that test voltage source you are going to get some current. The test voltage source is giving rise to some current. Get the ratio of test voltage to test current, that gives the Thevenin's resistance when no other voltage sources or current sources, no other sources must be present in the circuit. Ensure that no other sources are present in the circuit, and only you are going to apply a test voltage source across the terminals of interest. Because of that you are going to get some current. Get the ratio of the test voltage and test current, that will be giving the R Thevenin's. You can understand in this way. So now P and Q are the interested terminals. Apply a test voltage source, say V as the test voltage source. When you apply V, this voltage source is giving rise to some current as I. And remember that by that time there must not be any voltage, any sources present in the circuit. If any voltage source is present, at that time it must be replaced with a short circuit, and if any current source is present, it must be replaced with open circuit. But here we have only voltage source, so make it as a short circuit. Make it as a short circuit. Whenever you made it as a short circuit, this resistor will not be having any effect on the circuit, so no need to consider this resistor. Is it clear? So RTH is now written as RTH is equal to V divided by I, test voltage divided by the current drawn from the test voltage source. V by I is the actual RTH. So we are going to calculate now what is V, what is I from this circuit, and then you can calculate RTH. So first step, since you are applying a voltage V across P and Q terminals, the voltage across this 1 ohm is also V, because both are in parallel. So first equation you can write V is equal to V from the equation, V is equal to voltage drop across 1 ohm. Voltage drop across 1 ohm means I naught into 1 ohm, that is equal to V is equal to I naught volts. This is first equation and it is second equation. Next, calculate I. I is the current flowing through this one, so the current going from V is also entering from into V. So this is the current I and this is the current I naught. So you can write, if you are taking the current direction in this way, then it will be written as I minus I naught. If this current is I minus I naught, and both are going to be gets added, I naught get cancelled, what you are going to get is resultant is capital I. So this current will be I minus I naught. If you are taking the opposite direction, then it is I naught minus capital I. You should write it as, now I have taken the current direction, I have chosen as in this direction, which is same as I, so I am writing it as capital I minus I naught. If I have chosen the opposite direction, then this must be I naught minus I. Now write KVL for this loop. KVL for this loop starting from this point. At any point you can start and you can end up at that point, that completes the loop. So write KVL going through that loop, and voltage across these two nodes is same as 3I naught, because 3I naught is the dependent voltage source which is across these two terminals. So across this 1 ohm, the voltage across this 1 ohm is 3I naught. So you can write 3I naught and the direction is shown, KVL direction is as shown, 3I0 plus 3I0 minus, okay, same direction means I am going with opposite sign, 3I0 minus I0 into 1 ohm plus I minus I0 into 1 ohm is equal to 0. So you can write it as 3I0 minus I0 plus I minus I0 is equal to 0. So this you can write it as 3I0 minus 2I0 plus I is equal to 0. So from this one you can write I is equal to minus I0. This is third equation. And RTH can be calculated from V by I. V is given as I0 and I0 is minus I0. I0 get cancels. What you will get is minus 1. So Thevenin's equivalent resistance across P and Q terminals as minus 1 ohm. The right answer for this question is 1 ohm. You can also do the same problem, okay, in a different method, where instead of applying a voltage source, okay, you can apply a known current source. Okay, second method we will see. So second method, in this second method, across the terminals of interest where you are going to calculate RTH, okay, there you are going to apply a known current source. So assume that one you are going to apply a 1 ampere, and if you are applying 1 ampere across this one, you are going to get some voltage drop across these terminals, and say that voltage as V or something as Vx. Vx is the voltage source across P and Q because of known current source 1 ampere. So now RTH can be written as voltage across PQ divided by the 1 ampere. So Vx divided by 1 ampere. So this will be Vx by 1. So simply whatever the value of Vx, okay, that will be RTH. Now you need to calculate Vx. If you calculate Vx, that is sufficient. Okay, so Vx can be calculated from this one. Vx is the voltage drop across 1 ohm. So Vx can be written as I0 into 1 ohm, that is I0 volts. But we don't know the value of I0. So calculate I0 value from the given circuit. Okay, we know Vx is equal to I0, but we don't know the value of I0. So calculate I0. Calculate I0 from the KVL, again from KVL. And again, when you are applying this 1 ampere, the other voltage sources or other sources must not be present. So that indicates this 10 volts is acting as short circuit. So no need to consider this 1 ohm. Again apply KVL in the same direction. So if you apply KVL in the same direction, again it is 3I0, okay, minus I0 into 1 ohm, and this current, okay, this current will become 1 minus I0. Previously it was written as I minus I0. Now that I is known value, that is 1 ampere, so it is written as 1 minus I0. So this will be plus 1 minus I0 is equal to 0. So 3I0 minus 2I0 plus 1 is equal to 0. From this, I0 is equal to minus 1 amperes. So I0 we have calculated from this one. RTH is equal to, okay, Vx. Vx is equal to I0. That means minus 1 volt. So RTH is equal to Vx by 1 ampere. That means 1 volt by 1 ampere. So RTH is equal to 1 ohm. Sorry, RTH is equal to minus 1 ohm. Vx is minus 1. Minus 1 divided by 1 is minus 1. So minus 1 ohms. the RTH value is -1 ohms. This is the required answer. Thank you.